NASA, the National Aeronautics and Space Administration, presents Aeronautics and Space Report. This parachute test took place more than 24 miles above the Earth. The purpose? Help find out the problems of lowering unmanned scientific instruments through the thin atmospheres of some of our neighboring planets. Balloons and small rockets have been used to place the parachutes into the thin atmosphere high above the Earth, which is comparable to that of the planets. Also being tested, a model of a wheel-shaped planetary landing craft. Here, engineers prepare the lander for a helicopter drop over the Mojave Desert in California. NASA's Jet Propulsion Laboratory in Pasadena is conducting this research.
We have recently completed a test of that portion of the mission where we dropped the system from a helicopter from an altitude of 250 feet, which simulates the impact conditions which would be obtained on Mars in an actual mission. The impact velocity is in the vicinity of 80 miles per hour. On an actual Mars mission, immediately after landing, the radio transmitter would turn on. 3 minutes after landing, a wind instrument housed on top of a telescoping boom would be deployed. Atmospheric properties, wind, pressure, temperature, water vapor, and the major constituents of the Mars atmosphere would be transmitted back in the first 20-minute period, and again at the end of the first day. We believe that these tests have proven that the basic capabilities for entering and landing on the surface of Mars have been demonstrated.
During the Gemini spacewalks, it was found that a man, while weightless, has a tough time performing even the simplest work tasks. Since then, astronauts have been practicing underwater, the nearest thing to zero G here on Earth. At the Manned Spacecraft Center in Houston, fully space-suited astronauts learn to maneuver through openings similar in size and shape to those which they will one day encounter during space missions. This man is climbing into a mock-up of the lunar module. It is in the lunar module that two men will actually land on the moon. Here, the underwater spacemen are monitored by closed-circuit television. At NASA's Ames Research Center in California, engineers have designed a restraint device which provides the weightless astronaut with artificial gravity. The astronaut is attached by special harness to a wheeled apparatus that runs on a track and provides a constant force. This holds him against the spacecraft's structure, giving him normal traction. This particular device would be most useful in an orbital space station, allowing the man to walk, sit, and stand while weightless. A restraint system like this also means that many special space tools may no longer be necessary. Underwater simulations, providing practice for the astronauts and helping solve many of the problems associated with weightlessness in space. This has been an Aeronautics and Space Report presented by NASA, the National Aeronautics and Space Administration.